Hi everyone, my name is Hafsa Ibrahim from Dubai National School. I'm in grade 10, I'm 15 years old, and today I'll be explaining a physics concept. I will be explaining the potential energy. Now, can you guess what is the potential energy? Potential energy is defined as the energy of position, and there are two main types: gravitational potential energy and elastic potential energy. Potential energy can be turned to kinetic energy, which is the energy of motion, and then to other forms like electric energy. I'll start to explain the gravitational potential energy, which is potential energy associated with the gravitational field. Its formula mgh, which is basically mass times free fall acceleration times height. M is mass, g is gravity, h is height. Everything must be in SI unit. M, kilogram, g, meter per second squared, h, meter. As a result, the SI unit of gravitational potential energy is joules, which we use capital J. The height depends on the zero level chosen where PEG equals 0. Let's see how questions come according to the following figure. Find the potential energy of the mass. Find the potential energy, then the potential energy in the midpoint of the figure. To calculate the gravitational potential energy, we have to use the formula mgh. Everything is given, so simply multiply then divide by 2 to find the midpoint. 12 times 9.81 times 3.4 equals 400 joules. To find the midpoint, divide by 2, which is 200 joules. Easy, simple, straightforward. Elastic potential energy is stored in the configuration of material or physical system. When it is deformed by work, elastic potential energy occurs when objects are compressed, stretched, or generally deformed in any manner. PE elastic is calculated as half k x squared, where k is the spring constant, x is the distance compressed or stretched, and don't forget, it's squared. The spring constant depends on the stiffness of the spring. Stiff springs have higher k values, measured in Newton per meter. Force in Newton needed to stretch a spring 1 meter. What are the SI units for PE elastic? For sure, it will be joules. When we compress a spring, the force we exert is stored in the spring as elastic potential energy, which is released when we move our hand, allowing the spring to bounce back and return to its original position. When a 2 kg mass is attached to a vertical spring, the spring is stretched 10 cm, such that the mass is 50 cm above the table. What is the gravitational potential energy associated with the mass relative to the table? What is the spring elastic potential energy if the spring constant is 400 Newton per meter? Before calculating, be sure that everything is in SI unit. Question 1 asks to find the gravitational potential energy, so we need to use mgh. Question 2 wants us to find the PE elastic, which is 0.5 times 400 times 0.1 squared equals 2 joules. Potential energy is directly proportional to k and x squared. since potential energy is directly proportional to K and X squared. If K doubles by 2, potential energy will also doubles by 2. If K decreased by 1 over 3, potential energy also will decrease by 1 over 3. If X doubles by 3, potential energy will doubles by 9. And if X decreased by 1 over 2, potential energy will decrease by 1 over 4.